So we have started functions last time, and we literally had our introductory function defined. That is a function that will simply, when I execute it, it will say hello world. And if I don't like hello world, well, if I want to things be a little more personal, I will say, well, hello, Masha. So when I execute it, it's going to say hello, Masha. Okay? Now, this function, the whole point of creating a function is taking a piece of code that you have worked out, okay, and allow it to be repeated. Okay? Because you want to repeat it over and over again, and you don't want to retype the entire piece of code all over again. At some point also, once you work something out, you want to hide it away and just have it done so you can focus on things that are not done or build more complex things. So there's a lot of functions that we already have been using, like print, okay, or np.arrange, or any of those that seem to take some input from us and then execute something in an expected way. Okay? So there is a way for us to actually give something to this function and then let function work with it. So let's actually do an example of that. I'm going to again define something very simple so that we can focus on just the mechanics of how do I create a function. I'm going to do a function that adds two numbers. Okay? We already have that. Plus works just fine. Okay? But we're going to define a new function plus that will take two inputs A and B and add them up. So whatever I give in the regular type of brackets, okay, to the function is input to that function. So those are my input variables that I work with inside the function. And I have that mandatory colon. After colon, I need to indent the block of code that belongs to this function. Okay? And if I put in a colon, Jupyter Notebook is smart enough to indent for me. If I have some editor that is not smart enough, then I have to indent myself. 4 spaces. Okay? So let's say that there's some sum that I'm computing. I'm going to call it A. S is A plus B. So now my S is computing. I have to give it back. And often I will actually do a whole lot of stuff in function, possibly create some arrays that are auxiliary arrays for whatever it is that I'm working on. I don't want all of them out. Okay? I want only the final product. Everything else I want cleaned up, and that's also a purpose of a function. I will go, I open when I get home today, I get into the kitchen, I make all kinds of mess while working in the kitchen. I put inputs from the fridge, I throw them into the pot, I make a lot of dirty dishes, I'm a messy cook, and then I go out and I close that door, and I put the dinner on the table in the dining room. Nobody knows what the mess I made in the kitchen stays in the kitchen. I don't buy the open concept where you have kitchen right next to your stuff. No, it doesn't work for me. I make too much mess. So I don't like whoever is eating with me to see what I did. Okay? So that's part of it. Function cleans up, and that stays in the kitchen, along with all of the burnt pans and whatever else might be a product of my cooking. Okay? So you just want to leave that in the function and pass out only the final product, because that's what you care about. And that will simplify your workflow. Okay? So here we're going to pass out S. And we're going to say return S. Okay? So this is definition of the function. Let's see if I defined it properly. It's not going to complain. Fine, great. It doesn't complain. Okay? So now actually if I want to work with it, okay, I'm going to execute it, and I'm going to do that in the same cell. I'm going to say, hey, C equals to plus of AB. The only problem is that I don't know what AB is. I didn't define them yet, so I can say A equals to 4 and B equals to 5. And then execute. nobody's complaining. I did something right. The only thing, of course, I need to print that C to see the result. And the result is 9. Great. This is all you need to, give or take, all you need to know about the function. You give it inputs, okay? You do something in the function. This piece of code can be as complex as you'd like it to be, okay? I could do one of those for loops, okay? Let's do something. I'm going to do this so that I can...
Masha, sorry. Can you explain again what was the return?
Return is that I take the product that I computed that is important to me and I give it back. But only that product. Nothing else. So here I have only one.
What do you mean by give it back?
To the user. Otherwise it lives only inside the function. It lives only inside the kitchen. That burnt pan, you don't want to return. You want to return just your beautiful dinner, right? So this is the beautiful dinner you're putting on the table. The rest, nobody in the dining room will know about it. Okay? So outside of the function, I only know about this. And outside of the function, I call it C. I don't call it S. I don't even know what code calls it. Okay? Let's actually exemplify that. Let's print S. Bomb. Outside of the function, I don't know what S is. And I'm talking about cooking. Most of you probably don't cook. I didn't cook when I was 22. But maybe I can translate it like this. What happens in Vegas stays in Vegas. Or Cabo San Lucas, or wherever you go for spring break. Okay? So, basically, whatever you have in there, like I don't know about S outside of the function. Function called it S, and it passed it by. When it came to me, I called it C. I decided to call it C. And that's great because I don't know what the function, all of the internal workings on the print function, you don't want to know. Okay? You just won't know that it works. And the result, and you call the result the way you want to call the result. So that's by design, and that makes sense if you think about it. So S, we don't know, we do not know what S is outside of the function. The result of the operation we are calling C. And I'm going to comment this because it bombs. Okay? Now, I can do this code inside as complex as you want it to be. So one of these we wanted to sum up sum of x. I'm going to call it sum of x. And let's say that my x is my array. Okay? And I want to sum up all of its elements. And we had those for loops to do that. Okay, so let's say that S I initialize as a 0. Then I do a for loop, if you remember that. In what range? And then say S is S plus X of I. So now I'm computing sum of all of the arrays. And this is simply the exercise we had last time, summing up what we can do squares, not problem. We can do whatever we want to do. Okay? And then I'm returning that as. My input has changed, but as long as I'm working with that input in a legal way, using proper syntax, no problem. So now that's my result.
How does the function know that you're passing an array?
By me working with it. So when I pass an object to the function, that object travels with the specification of what it is. And as long as all of whatever it is that I'm doing in the function works for that object, no problem. So what I'm going to pass to this, right now I didn't pass anything to the function. Function is not working yet. But once I actually call the function to work, So let's see whether I did anything. So syntax is fine as is, but let's actually call it to work. First, I need an array. And I'm going to define myself an array. Which way do you want to define the array? Give me a function that will define an array. Array. She wants np.array. Fine. We can do that. And then give it something. 3, 4, 9. Whatever. Okay. So now x is an object. It's an NP array. And when I give it to the function knows it's an NP array. So as long as whatever it is, the code that I have in the function that is literally going to get executed for that x or whatever, I can call it something else, by the way. It doesn't have to be x. Outside, I don't know what function, let's call it y. So now when I call that function with y, I'm going to give y. Okay? You pass me something, Oh, okay. I know what this object is. That's what literally function does, right? This is a cover for glasses. It's not a baby. It's not a cookie. I can't eat it. So when I see it, right, I recognize it. Well, the way computing system, there's a class of the object that travels with the object. So when I give that object to something, function will be like, aha, it's an NP array. Because that information actually travels with its name once you define it. Okay? So I know a little something about that object. Or at least that's how these functions work. So as long as everything that I have inside of this function works with NP arrays, and everything that we did in there does, no problem. Okay? Does that sink in with everybody? Okay? So the question was, what is legal thing to do inside a function, given that I didn't tell the function what that x is, or AB before? Okay. Great, so let's now call this sum of x, and that's this is bad choice of a name, since I'm going to call my variable y. So how you choose to name the function is up to you. It's part of your design. Naming it well so that it's intuitive for people who are going to use it is important. Okay? Sometimes you feel uninspired on a Friday morning because it's been a long week. So then you start calling things 1, 2, 3. That means nothing. It's very good to actually say, say in short, not too long because people have to type it in, but in short, print is print, right? Print, we know what it is. Range, it gives me some idea that I'm going to get a range of numbers, right? So meaningful name that is not too long is an important thing. Anyway, the sum of x is a bad choice of a name, bad design, but I'm not going to change it right now. So sum of y, and then I can call this sum something. Sum of y equals to sum of x of y. I'm going to continue with my bad design and get stuck in it. No, I'm going to change the example soon. So, okay, and then I can print it to see what it is. Let's see if this works. 6190. Sum of squares, even better. So speaking of a bad choice of a name, I can also print just to test. So this is now testing. I'm testing whether the function works as designed. Plus 4 plus 78 plus 9. Oops, 2. And I should not have type. So I'm basically literally testing on this array whether the function does what I told it to do. And since I get, is this testing enough? It is for now. Okay. So testing is never, I didn't test all of the possible cases. I didn't test different arrays. Testing is difficult to do. You do some of the testing, and then you kind of move on. But you can expect that as you get some new data or you try this function with something new, it might bump. Okay? It might produce incorrect results in cases that you didn't test. So be aware of that. Just be mindful of that. You can always do only limited amount of testing and then you move on. Yes?
Okay, just get confused. On the first line, you said you define the S is equal to 0.
Yes. And then I change it.
So
This is summing up all of the squares of the array elements. So I just keep changing this S, and the end of this, I have computed pretty much for this array, this is what I computed. So I took every element, squared it, and then add them all up.
So if you don't define the S as a 0,
It's not gonna know what is, then it's gonna bomb. Let's do that. So the problem is that I did not initialize it, and suddenly I'm talking about S here. And if it doesn't, that's why initialization is an important part whenever doing anything.
okay, and it has to be 0, or it can just be any number.
It can be any number as far as computer is concerned, but then I'm not doing the sum of, right? So you can do what you want to do legally in all kinds of ways. The question is it meaningful for what you need to do? So maybe it is meaningful, right? Let's say that I was adding up, I have pressure differentials, right? Over a column of data, like I have measurements and I have differentials, right? I have a bunch of transducers and each one of them is giving me differential pressure. To sum up the pressure in the column, I just sum them up. But at the bottom is not 0. At the bottom is some pressure. Then I would add that pressure here, okay? But that's a physical problem that has a specific physical solution. Here I'm whipping up an example out of the air. So out of the air, anything works. And computer is fine with it as long as you initialize it.
Okay, so you mean if you want to find the product of some numbers, this has to define as 1?
No, yes. Product has to be 1, otherwise it's going to be 0, right? I don't have to have a function for that. I know that the result will be 0 if I initialize it as 0. Okay? So this initialization, it's an important concept in computing that you don't necessarily conceptually think about. When you're conceptually solving the problem in your head, you don't need to initialize because your brain already is thinking about it, right? But a computer is not thinking. The computer is simply doing what you're telling it to do. Right? And it has to start from something. Okay? 0 is a common starting point if you know nothing, right, about the problem, and then you adjust it as you go. Okay, with whatever measurements or anything that comes in. Any other questions?
Yeah.
Yes.
Whenever I indent the return, it gets some numbers in red. What is it do?
So indent means that I'm part of that function.
So it'll change the number.
Yes, because, great question. So if I indent the return more than I did, it's part of the for loop. So you're going to return, first time you enter the for loop, you're going to return, and you're going to be out. Okay? Return is immediate exit. What's that name in Monopoly thing? Out of jail something. Yeah, okay? Out of jail. I haven't played Monopoly in years.
Destroys families.
So, huh?
It destroys families.
He has, but it's not a good family. It's not a unifying exercise in the family. It's a splitting exercise. Okay. So, this is immediate eject. You know, you get ejected from the function. So watch out where you call it. Okay? Because that's going to change the result, because then my sum will only have the first element. And after the first element, I'm going to get ejected, so my sum is different. Which is fine, maybe that's what you want. Computer doesn't know. So it's a legal thing to do. But watch out, if I put return here, return is part of the block for for statement. Okay? So I'm going to say, watch not to indent too much, or return will be part of for loop. And you might want that or not. Okay? But if you're going to return first time you enter the for loop, why did you call a for loop? It's a little... Okay, any other questions before we move on?
I think I got the same number as before, 9. What I said.
Well, for 9, if you added two numbers A and B, yes. But if you did this, then...
Yeah, exactly. I got the same return as 9. I don't know why.
Because 9 is 3 squared.
Oh,
That's that first element. So yes,
so it was because of the indent as well?
see?
Oh my.
I got ejected out of the for loop after the first number was added, and then I stopped. And that's 3 squared happens to be 9.
Oh, so this was with an indent mistake as well?
Yeah.
So we should always...
Well, not always, depends what you want to do. In this case, we want to return S after the entire for loop executes. Therefore, you have to be aligned with 4, not indented from 4. Okay, great questions. All right, now let's say,
Yes.
let's start with this plus function again. Copy it down there. And I'm going to say plus prod. Prod. You call it Prodanovich now. Yes.
Wait, is that something you call anything, the function? The plus prod?
I can give it a name I want. And if I'm vain, which I rarely am, I can call it Prodanovich. But that, remember the smart naming of functions? This is a tough speller. Nobody will use your function if you call it Prodanovich. So, it's not a good one for typing. If I want to sell myself a little better, maybe how about Pro? Okay, Dr. Pro. I'll take that. Okay, so I'll call this function Pro. You can call it whatever you want. Now let's say that we also want to, what I wanted to say with that prod, I want to do both addition and multiplication. So I want to create product A times B. Now I want to return both of those. Okay? And if I want to return both of those, I will just say comma. So again, this works like just with comma, you separate individual things you want to return. So these are function products, or whatever I compute and I return back. And these are function inputs. This is what I'm working with. Now, to actually be able to catch that from the outside, so we were calling function C equals to, now I have to call it pro AB. And I don't have to have AB. I can put 56 and 100 here. Any numbers will do. I can define them as variables. I don't have to define them as variables, whatever it is that you want to do. Now I can say C comma D, and then I will catch both sum and product in two different variables, and I decided to call them C and D. And of course, it doesn't tell me anything until I actually print C and print D.
Could you not put commas for printing?
I could. I wanted them separate, so I know who's who.
So you don't even have to define A or B.
No, you can give function to work with anything that it knows about. So if I defined A and B as variables and I pass that as input, that works. Or if I have numbers that I pass as input, that works too. Okay? I could actually say Z equals, so let's see what happens. I'll actually give it a new, I'm going to execute it here. So Z equals to pro 5600. And I'm going to say print Z. So if I give it only one thing to catch the output, okay? So she's throwing me a ball or whatever this object was here, glasses cover from the function. And let's say she throws me two things, okay? I'm going to catch that from the outside with Z, And what the Python will do, not every environment works that way, it will create an array and it will put first thing in the 0th element of that array and second thing in the first. And if there was more, it will continue. So it will create a collection of objects, not really an NP. It's not an NP array. Okay. So basically, to get those back, you can print z of 0. Okay. So you kind of bundle them into a list of objects, and you get the individual pieces by referring to the 0th, first, and so forth, however many elements there were. Okay. So again, function is throwing things back. Python is like, okay, I'm going to catch all of it and store it sort of in different bins in this list.
Is that pro a sum or product?
Product.
Both. I'm computing sum and product. And this is this bad naming, right? By naming it pro, you have no idea what's in there. So don't use vanity when defining your functions. Technically, the best would be to call this sum product. Okay, but then I have to change the naming as I call it. Oops. Oh, and I executed only this cell before executing this one, and it's telling me, well, what on earth is sum product? You didn't define it. Again, computer is doing just what we tell it to do. Now it's going to be fine when I refreshed both. So these cells are useful in Notebook. They're useful because they can kind of isolate the piece, but they can also be annoying because they're isolating things. And so if you don't re-execute everything that is important, then you're not going to know about it. So if you make a change, you have to go and execute all of the cells that are relevant to it.
And the Z0 refers to the sum and Z1 to the
Yes. And you kind of have to know that. You know, what is function doing? So good programming practice is to give yourself in the code. Now this code it's pretty obvious what I'm doing, but this is also not worth doing because it's so obvious, right? So most often you will program something that is more complex, and as you go you should leave comments. So compute sum of A and B, and then compute product of A and B. Okay? So for function, you might want to leave comments. Sum product takes two inputs, A, B, and produces and computes sum and product. Or maybe returns. And you can be a little more structured and clean in how you write this. My point is that you can write whatever you want as comments. It should be helpful to the person who will potentially review this function and see how to use it. Okay. I'll take this one step further because I think that's really the cool part in terms of being flexible. So you have noticed that print function, you can kind of give it a lot of things. You just put commas and keeps going. So Python takes that list of things as a list or a collection and it goes one by one and prints it. So it actually kind of takes the cumulative, because of the commas, it knows how many. Okay? It literally goes and counts commas and how many things they have there, separated by commas. So it's going to figure out, so the way to do that, you can do that too. So this is how to define a variable number of inputs. And I'm still gonna work with plus function. I'm just gonna call it plus variable, plus var. And the way to tell Python, hey, there might be multiple things coming, is to put a star. And I'm going to have to call those arguments args. That's actually a common way to call them in programming. So star args is telling it, hey, there might be one, there might be, well, with one, I don't know that I want to do a sum, but whatever, but maybe 2, 3, 4, and so forth. And then I'm going to work with those arguments as follows. Let me see, 4, there we go. I'm going to say for I in range of length of these arguments. So it's going to inspect these arguments and figure out the length of that list, how many I have in the list. I'll print this argument just to have double check of what it's doing. And I'm going to say S is S plus args of I. And the only thing that I didn't do before starting this is initialize S to 0. So is this piece of code clear? I give it a list. Because of the star, Python knows, oh, this list might have variable arguments, not like 3, 4, 7, but some number of them. And I'm going to inspect how many here. And when I define it this way, then each argument that I pass is actually part of that list. Like I can refer to it as a list member. Args of 0, args of 1, args of 2, up to however many there are. So this for loops literally loops through all of them. Here I'm going to print them for me just to see what the hell is it doing. Excuse my French. And then I'm going to add them up. And I'm going to return that result. So this is something that is flexible. So let's give it a try. I'm going to say plus print, or I'm going to say C is plus var. First, I'm going to test it with the two I know about, 56 and 100, and print C. And then I'm going to get more bold, and I'm going to say, hey, plus var of 67, 56, and 100. So let's see if it works if I give it 3. Ready? Let's test. Let's see if I made any mistakes. Uh-oh, I did not. Okay, so this was actually, but I didn't know so let's see. Print. Next test. Separate them a little. Okay, so my first test, it printed 56, then it printed 100, it kept adding them, and it returned, I'm printing this sum as 156. My next test, 67, 56, and 100 in the order they came in, and 223, that does seem to be correct sum. I can keep going. It's going to keep going. That's powerful. Okay? So that's flexible. Flexible is good. How far can I push this? So now I'm testing it with numbers. It works for as many numbers as I could. What happens if I make a mistake or I have no clue how this works? So I'm going to do next test. F is plus var. I'm going to give it a string, pro, and 67. What does it do now? It's a little bit of problem summing those two up. Okay. Doesn't know what to do with a string plus number. The function is still defined. If it works, it works. If it not, it's going to bomb on me on my... This is like I'm testing and I can push things up to a limit that my, whatever I defined works. But, well, maybe, what happens if I... Yeah, it doesn't know how to add that either. So plus doesn't really work nicely with strings, that's the point. Nominally, the code is fine, right? The function is defined, but when I call it with sort of illegal elements, it's gonna try, but if it doesn't work, it printed the first one, so the printing works with strings, right? If I was just defining my function without summing anything up, and I was just printing things, then I can actually execute this one. Print first string, print second string, and get out. And my sum is actually 0 because I just initialized it as 0 and I didn't do anything else. Subtle difference. Does everybody see the difference? So these, whatever I defined here, works with strings, works with numbers, works with anything print works with, and print works with anything. Okay? But it also doesn't do anything useful, right? It's just printing things back to me. So I'm going to go back to this. Okay.
So why doesn't that work whenever you pass it a list?
So it has this plus operation, can't keep adding strings with a plus, effectively, within the for loop. So that's the limitation of the plus operator. That's all. But if I put an operator that was, I could, so the way print works with everything. But that's because there's a long code inspecting what is the object coming in. So if the object is this, do that. If the object is array, do this. If the object is a string, do this. If the object is, it keeps going like that. So you can print a lot of things because somebody has programmed print to work with everything. Does that make sense? And people have been working in it for a while, so there's like a pretty long function print. And you can probably find the code for it if you go online. Because that's the meaning of Python being open source. The code is posted for everybody to see. So you can actually go and find the code for function print. When you are going to a software that you purchased, some of it might be open to you to see, but some of it might be like saying, sorry, this is our product, this is what we sell, and we're not giving this secret out. So there's a way to package products when you install them to figure out how much information you give back about the actual product. Okay, here's an assignment. And I'm going to type in so that you have, I'm going to type in the assignment so you have the things. So we're going to do a so-called Monte Carlo simulation of number p, or pi, however you want to call it. Okay. So I'm going to first do a script. So we're going to solve this as a script, and then we're going to package it as a function that has more variables. So here's the idea of Monte Carlo simulation. I'm going to give it an area that is going to be a square, of known square. Then I'm going to randomly throw dots into that square. And for those dots, I'm going to check how many of these randomly generated dots are falling within a circle. Okay? Everybody following me yet? And then I'm going to find the fraction of this dots that fell into a circle. That should give me an idea about the area of the circle relative to the square. Yes? Okay. So basically I'm going to say, okay, especially as I throw in more and more points in there, this should be close, this ratio should be close to the ratio of the area of the array and area of the square. Basically, and that's the probabilistic way of looking at it, right? Okay, so I have my chance of hitting the circle is commensurate with the area of that circle. But area of a circle has pi in it. Okay? So I can then try to gauge what number pi is based on that. Okay? All right, is everybody following? So I'm gonna type that up now, that story. Area of -1, 1 by -1, 1 is 2 by 2, it's 4. Right? So I'm gonna area of a circle with center 0, 0 and radius 1 is that 1 square times pi, right? 1 square. Well, I'm just going to say it's pi. It's 1 square pi, right? So if I throw or create n points in -1 on, okay, randomly, then the number of those points that falls into the circle should be commensurate with circle area. Do we agree with those statements that I made so far? Okay. So let's, our first task is create endpoints. So create endpoints within and count how many fall inside the circle. That's the task for now. We're going to build this little by little. So this is where I'm going. This is my plan, and this is how I have to plan. I want to ultimately measure pi, and I want to kind of get to, see how sensitive that measurement is to the number of points that I test with. Okay? So what I want to do is first actually create this script that just finds the number of points that falls inside the circle. Then I actually want to create a function that does that on demand by changing this n. So n will be input of the function. So I can test it easily with 10, 20, 1,000, 10,000, and so forth, because I want to test things. Right? But my first step is just creating this computationally. This is the core of the task. Okay? And then I'm going to package it into a function that I can execute as well. Okay? Let's do that. Or let's start doing it. So actually, why don't you start doing it so you're not just, this is for loops and using rand function and testing that whatever you create. So you need x and y's. Everybody's delighted with that idea. You were ready to copy the code I write. I know. I gotcha. So step one, will be create those functions. Then I'm gonna write down steps 2. Will be plot those points. Different mark for circle ones, the ones within the circle. Step 3, package this into a function. Oh no, step 3, estimate pi depending on those areas. And step 4, package this into a function with input n and output pi estimate. So I hope conceptually it's clear what to do, and we'll see what kind of problems we're going to get while trying to do that. So start gently with n is equal to 20 while testing things. Just in case. And then somehow I create x and y's for these points. Somehow. And then once I create those points, test whether points are in circle. For I in that range, do something. I'm going to let you type this up. If you find yourself really bored this weekend, especially on Saturday night, work on this. After you get back from like visiting with friends or movies, let's compute something. Let's compute pi. I actually do that sometimes, but anyway, I'm me. So, and if not, we're gonna continue working on this on Monday.
Is that range or